Good evening, guys. For those that have just joined us, we are going to put together a great workshop for you guys today. Remember, today we're doing number patterns. And before we get started, one thing that's going to be a big part of what we're going to start with is a challenge question of the day. All right? Please remember, guys, as we're about to get started, please make sure if you've got any friends that are supposed to be here, let them know that they should come. This is indeed an interactive session, right? So we will give you lots of chances to interact, lots of chances to ask questions and everything as such. So please remember, let's keep some etiquette or ground rules for the day. Please remember that when you join, please mute yourself. If you want to ask questions, put your hand up and then we will allow you to do that. Or if you can ask your question simply by posting in the chat, and then we will look at the chat and we will respond from there. So before we get started on number patterns today, we've got a challenge question of the day for you guys. I'm going to give you guys 5 to 7 minutes to try and solve this one. The challenge question goes as follows. NOMSA generates a sequence which is both arithmetic and geometric. The first term of this sequence is the number 1. He claims that there's only one such sequence. Is that correct? Show all you're working to justify your answer. So I'm going to give you guys 5 minutes for our challenge question for today. NOMSA generates a sequence which is both arithmetic and geometric. The first term of a sequence is 1. He claims that there's only one such sequence. Is that correct? Show all your workings to justify your answer. I'm going to give you guys 5 to 7 minutes to try this question. And then as soon as you are done, maybe put your hand up or post in the chat to say, I'm ready to share my answers. And then we'll see if you guys are able to solve this one. Now I'll just confirm on your side that you can see my screen and you can hear me on Zoom and on TikTok.
I can see your screen and hear you on Zoom.
Okay. For those that have just joined us, please just double check. We've got a question that's up on the screen. Our question is going to be, NOMSA generates a sequence, which is both arithmetic and geometric. The first term is the number 1. She claims that there's only one such sequence. Is that correct? Show all your workings to justify your answer. I'm giving everyone 5 minutes at the beginning of the session to test this out, and then just to see if you guys are able to solve this particular problem. All right. Remember, guys, it's very important. We are running these sessions to be able to help you guys get, if you're sitting somewhere at a level 4, 5, or 6, we want you sitting up there in the high level 6s into the level 7s, right? And part of what will make you a high level 7 high level 6 and a level 7 student is being able to do critical thinking, to do logical reasoning. And questions like this will really always help you into trying to solve, how can you solve problems that seem a little bit non-routine, slightly higher order. So give this question a try. And then when you think you've got the answer, you are more than welcome to post in the chat to say, yeah, I think I know how to do it. Post in the chat in the meantime. And what we will do is at the end of the session, we will go through how this answer is actually done. Post in the chat. If you guys are going to help each other, you can communicate in the chat to help each other. We will go through the answer of this at the end of today's lesson. So you better stay tuned all the way through. I'm going to give you guys 3 more minutes with this question. Then we will start with today's lesson just now.
I'm not talking.
Okay, I haven't seen anyone posting some of their solutions in the chat just yet. I know it's a little bit of a tricky question, right? Because it requires you to think in a way that's different to how you've maybe been taught to think at school. But I want you guys to try. If you're stuck, maybe post in the chat, ask someone to help you, and you guys can come to a solution together. I'm going to give you just under 2 minutes left. I hope you guys have done a good job at trying to make this question work. Before we start with the work today, I want to just remind you guys again, remember this is our road to prelims, right? We're helping you guys get ready for your preliminary examinations. Now we are going to really say, let's look at what is required for us to work and do our exams correctly and do our exams well. So we're going to start off with some exam techniques. So when looking at our exam techniques, it is very important that the following things be things that we really consider in a very strong way, right? So when we do our exam techniques, what we are looking to try and do is say there's 3 things to keep in mind. So there's time management, right? Time management is very important. When it comes to time management, you need to know how to allocate time and to spend each question. Using the mark allocation as a guide, it's very, very important. So when you get to a particular question and the question is asking you for whatever it might be, and it's 1 mark, it's going to be a single word, a single answer. It's what we tend to call recall questions. It's a question where you just jump in and you give the answer as it is, right? Simple calculation type based question. So that's also something that's very, very important when we do these things. Secondly, you want to start with the questions that you're comfortable with. So, as much as sometimes it might be tempting to get to an exam and start with question one and then just blitz your way through from question one right to the end, you need to start with the questions that you're comfortable with, right? Aim to collect as many marks as you can. Start by answering the questions you're most comfortable with. Attempt the low hanging fruits in each topic. So, for me, the key thing that's important to say, what is important is think about your confidence as you're busy writing a paper, right? Your confidence is important to keep it up there. When you're confident in the paper, you tend to give of your best, you tend to remember things very well. But when you're less confident, you tend to forget and you panic. So what builds your confidence? Building confidence is doing questions you know you can do well. It's doing those questions that you've been nailing the whole time, right? So that's also very important. So start the questions you're comfortable with. So if you know algebra is question one and math, but you know, listen, let's say, for example, finance is question three, and finance is your favorite topic, the topic that you tend to do well with. Go and start with finance because as you go, you want to be able to knock those marks down to think, okay, I need to get a particular level in a particular amount of time. One thing that some people really worry about is they worry about what if I fail? But remember, a 3 hour paper's got 150 marks. There's 50 marks per hour. That first hour, you collect your first 50 marks. That's how you secure your pass. So you don't have to worry about, am I even going to get through math? Secure your pass in the first 50, in the first hour. The next 2 hours are all about the quality of your pass. And this is why techniques like this are so, so, so very important for you guys to be able to do and take these things on. Then lastly, the one we need to think about again is neatness, right? So again, make sure that you write neatly and clearly for markers to see your work and give you the marks. Write down each step to give you all the marks allocated. I mentioned to the group that was doing physical science yesterday that imagine the person who's going to mark your exam had the worst day of their life, right? They woke up, there was load shedding again, it was back. They tried to go take a bath and there was no water. And they got outside, it was raining, their car was stuck. They have to go catch a bus, but there's lightning, and they just had the worst possible day, leading them up to having to mark your paper. That person is not going to be the most lenient or the most understandable person. So things like not allowing yourself to give people a chance to mark you down is very, very important. And neatness is one of the most important part of that. If you can write clearly, someone mustn't guess whether you wrote down a 5 or you wrote down a 6. They need to know very well exactly what you guys wrote down, right? That is very important that you guys need to do. So remember, time management is important. Start with the questions that you're comfortable with. And finally, neatness is very, very, very important in your exam technique. All right. Now that we're ready, I'm going to ask if anyone is keen to give us some of their answers for the challenge question that we had. For the guys on Zoom, I'll put the challenge question back up. Now, if you can check, I don't know if there's any of the guys on TikTok who might have also just joined and gave us answers for the challenge question. Is anyone keen to give us any of their answers for their challenge question? Now, if you're monitoring the TikTok live, just let me know if there's anyone there who posted on the TikTok live comment.
I'll let you know if there is any.
Okay, cool. No, that's fine. Okay, if no one's posted again, we'll give you guys the rest of the session to go. Right at the end of the session, we will be able to then take you guys through the answer. Your presenter for today is Mr. Kapang Kati. He is one of our great maths tutors that we've had for quite some time here at the Learning Space and the Pro Institute. And he's going to take you guys through an awesome session of number patterns. Kapang, if you are ready, you can take over my screen share and then I will hand it right over to you.
Ernest, I just got back in the meeting. I got kicked out. Did you hand over to me? Just got the last
Apologies.
bit.
Yes. Yes,
All
sorry.
right.
I was handing over to you. Sorry about that. You can
Okay,
take over
no.
on my
All
side.
right, okay. Thank you so much, Ernest. And I'm gonna just get started on my side. Okay, I'm gonna share my screen just now. Good evening, guys. We're going to get started just now. Bear with me for a second. Let me just share my screen. Ernest, can you please make me a co-host so I can share my screen?
Sorry, let me do that for you quickly.
Please confirm if you guys can see my screen share.
Yes, I can see your screen share.
Okay, perfect. Right. So let me just jump right into it. So we're going to get started with question 2 here. So it says, given the quadratic number pattern, right? Immediately, because they said it's quadratic, we know there's a first and there's a second difference. Okay, so that might be very, very helpful. Now, question 1 is saying, 2.1 is saying, write down the 5th and 6th terms of the pattern. Okay. Now, let's see how we can go about that. Okay, guys, can you please try to not draw on the screen because it can be a little bit distracting. So now I need to clear the screen share.
It's fine. I'll
Sure.
clear the drawing step and you can
Okay.
continue.
Thank you so much, Ernest. Okay, so we have 5, we have 9, 17, and 29. So what we're looking for is this term and that one there. All right. So now let's check what's the difference between 5 and 9. It's just 4. The difference here is 8, and there it's going to be 12. Okay. Now we know that we can see that there's a constant difference of 4. Okay, so we added a 4 to get to 8, we added another 4 to get to 12, so we're going to add another 4 to get to 16. So if we add 4, we're going to have 16 here. So 29 plus 16, that will give us 45. Then here, we need to add another 4 to get it to 20. So 45 plus 20, that'll give us 65. Then we have the 5th and 6th terms of the pattern. Okay? Now, 2.2. Show that the nth term of the quadratic pattern is given by Tn is equal to 2n squared minus 2n plus 5. That shouldn't be too bad at all, right? Let's see what we have. We know that the difference here is 4, so we're going to say 2a is equal to that, right? Now, we also know that 3a plus b is equal to that. Then, lastly, a plus b plus c will be equal to the first term. Then let's try to solve. So 2a is equal to 4, meaning that our a is 2. Then 3a plus b is equal to 4, and we know that because our a is 2, we can simply say 6 plus b is equal to 4, meaning that our b is minus 2. Okay? Now, lastly, we just need to find our c. We know that we have 2 minus 2 plus c equals to 5. I immediately substituted my a, my b. Right? Then I just need to solve for c. These two cancel each other out, which means that c is equal to 5. Then I can substitute into Tn is equal to an squared plus bn plus c. We know our a got it to be 2. It's just n. then our B was -2, and our C is 5. This is exactly what they were looking for. Okay, now next question. Is 2023 a term in the pattern? Motivate your answer with relevant calculations. Okay, now let's see how we can go about that. So what we need to do is we need to take this and equate it to 2023. Remember the nth term that we found? So we're simply going to say 2023 is equal to 2n squared minus 2n plus 5. Okay. Then we need to find what n is. Now, just going to say 0 is equal to 2n squared minus 2n. Then it's going to be minus 2018. Right? From here, it will be a little bit difficult to factorize that. So we're going to rely on the quadratic formula. So I know that n is equal to, I will substitute that. Let me just say x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This is under the root of c. Perfect. Now let's substitute the values that we have. We know that this is n and x. It's just for me to remember the quadratic formula quickly. Now that will just be 2, because negative, 2 plus or minus square root of 2 squared b squared. Actually, I can simplify this whole thing, but because I didn't simplify it, it's fine. I can work with it this way, where I have Tuesday. I could have divided everything by 2.
Note.
Yeah.
Sorry if you can hear me. You are writing a bit small, so it's hard to see. So I need you to write a lot bigger.
Okay, let me just
similar to like that number pattern you wrote on your top right, like that size.
Okay, so like this part here.
Yeah, like the top line. It gets
Okay.
smaller as you go down, but that top line.
Okay. All right, perfect. I will work on that. Thank you. All right, then remember we had our nth term, which was 2n squared minus 2n plus 5. So all I did is I took the nth term and I equated it to 2023. So I'm going to say 2023 is equal to 2n squared minus 2n plus 5. Then I want to get it in the form of ax squared plus bx plus c. So take the 2023 to the right-hand side so that you have 0 is equal to 0 is equal to 2n squared minus 2n minus 2018. Okay, now I can divide throughout by 2. If you didn't see that you can divide by 2, that's also fine. You're going to get the same answer. If you divide by 2, you're going to have 0 is equal to n squared minus n minus 1009. Okay, now all we need to do is use the quadratic formula there. So x is equal to negative b, which is just 1, plus or minus the square root of 1 squared, then minus 4, our a is 1, and our c is minus 1009. Close the bracket. This is all under the square root over 2 multiplied by 1. And let's just plug that into our calculators. We should be getting, let's just change this back to n, because we're not dealing with x, we are dealing with n in this case. So we're going to get n to be 32,27 or minus 31,27. Okay, now we found the value or values of n, right? Now we have to conclude. They said, is it a term in the pattern? We didn't conclude, right? Firstly, I'm going to look at the negative. Remember, when you have a number of terms, when you have a sequence of a series, you can find, starting with term 1, going term 2, term 3, term 4. But if I said to you, find term 1.5, you don't even know how to go about that. It's impossible. You know you have term 1 or term 2 or term 3, right? Or if I say to you, find term -2, that doesn't work, right? So the -1, immediately it's going to be out, right? Even the positive one is going to be out. Why? Because n is not a natural number. Okay, so our conclusion, no, n is not a natural number. Then we've concluded. Okay. I don't think there are any questions in the chat. Then I'm going to move on if there are no questions. Okay, perfect. Now, looking at the next one, question 3. Right, so we have
quick one. Sorry to interrupt you.
No
So for question 3, if you go right down to the bottom of where you're working, I've just made another space for you to work there.
Okay, perfect.
So just
Thank
go
you,
past all the way down, then you can at least do that, and at least you'll find the other questions there. There you go.
Oh, perfect. Thank you so much. This really helps. Thank you. Okay, looking at question 3 here, right? So they're saying evaluate. And what is it that we can see first? We see that we have sigma, right? The sum to a number of terms, right? Now, because we wanted the sum to those terms, it would be easy for us to at least try to make life easy for us to try and find the first few terms so that we can see if this sequence is geometric, arithmetic, or if it's quadratic. Right. Now let's see. Let's find the first 3 terms. So we're going to substitute k to be 1. So if you can't see properly there, we have sigma, k equals to 1. Then we have 50 here. And then function is just 30 minus 4k. That's the question, okay? Now let's find the first 3 terms. I'm just going to find them here on the right and then use the working on the left. Substitute k to be 1. You substitute k to be 1, you're going to have 26 because 30 minus 4 is just 26. The next one is going to be 22 because you have 30 minus 8. Next one is just going to be 18 because now you have 13 minus 12. Right. Now you can see that this is arithmetic, right? Arithmetic where our A is 26 and our common difference is minus 4. Be very careful. It must be minus 4 because as you can see, the terms are getting smaller and smaller. So we are subtracting, we are not adding. All right. Now let's check. What are we looking for? We are looking for the sum of 50 terms. So I'm saying it's 50 because we are starting at 1. You see, they say k is equal to 1, meaning that we start at 1, 2, 3, all the way until 50. You'll see that if you count, you'll actually reach 50 terms. But if they had said that k is starting at 3, then it won't be 50 terms. So if they had said k equals to 3 there at the bottom, it means that we are omitting 1, we're also omitting 2. So it's actually the 50 minus 2, which is going to be 48. You need to be very careful when you deal with these kind of questions. Now, we can go ahead and say Sn is equal to n over 2 into 2a plus into n minus 1 multiplied by the common difference. Okay, this formula is there on the formula sheet. You don't have to memorize it. Now let's substitute what we have. We also have our n. It's 50. Remember, I just showed you how to get n. In this case, it was 50 because k is starting at 1. Let's substitute. 50 divided by 2 into 2 multiplied by 26 plus 50 minus 1 multiplied by the common difference, which is minus 4. When you are here, can immediately just plug it into the calculator exactly like it is. And this should give you minus 3,600 600. This is S of 50 terms. The sum of 50 terms is equal to minus 3,600.
So it's about this request for you to repeat. I'm not sure which question they're referring to.
Okay, I'm assuming it's the sigma one.
I don't know. Maybe let's just unmute Poloso.
Okay. So he's saying 2.3.
Moses said 2.3. Yeah, there we go.
Okay, all right. I can quickly go back to 2.3 and then show you how I came about the answer. All right. So the question was just saying, is 2023 a term in the pattern? Okay. Remember that we have our nth term, right? The formula for the nth term. We calculated it and we found it to be 2n squared minus 2n plus 5. It was this one here. 2n squared minus 2n plus 5 for the pattern that we are dealing with. Now we're going to equate it to 2023, which is what I did here. So I just said 2023 is equal to 2n squared minus 2n plus 5. Then from here, I just subtracted 2023 on both sides, so I took the 2023 over to the right-hand side. We're gonna be left with 0 on the left-hand side is equal to 2n squared minus 2n minus 2018. Because the 5 is positive, the 2023 goes to the other side, it becomes negative, then that 5 adds there, so we are left with 2080. Now I divided every single term by 2. If you divide by 2, you're just going to have n squared minus n minus 1009. Okay, now we can see that is quadratic. We need to solve it, and for this, we can use the quadratic formula. Okay, remember, if this is confusing you, you can think of it in this form. 0 is equal to x squared minus x minus 1009. Then you can use the quadratic formula. But if you're going to use x's, remember to always substitute back at the end, because here we're not looking for x, we're looking for n. Right? This is just to make your life easy. Then use quadratic formula. Our a value, this is 1. Our b value is 1. Our c value, so our b value is minus 1. Our c value is minus 1009. Okay, quadratic formula, substitute. Now, once you get you're going to get your 2 answers on the calculator. Both of them are going to be decimals. The other one is just negative and the other one is positive. So the negative one, you know, whenever you're dealing with number of terms, you can start at term 1, you can go to term 2, term 3. If I said to you, find term negative 1 on a number pattern, that would be very difficult. It's impossible for you to find it. Right? Now, if I say to you, find term 1.5 as well, that would be difficult. You won't even know how to go about it. You only have term 1, term 2, 3, right? Meaning that it must be a natural number. And because when we substitute 2023, we're not getting a natural number, then 2023 is not a term in the pattern. And just by doing it this way, we'll get our 4 marks there. Hope Moses is covered. I don't know if Poloso had the same question. Yeah, fine. Then we can move on to the next one. Okay, now let's look at question 4.
Hi, Tabang. Sorry, just a quick one. Do you mind on your screen? You see those lines next to the mark allocation 4?
Yes.
Can you zoom in until that point of your screen? Until that line. So don't increase it, just zoom in until that is on the right hand side. Then at least just right underneath. Yeah, like that. And then right underneath. No, that's too big. The previous one is fine. 125. Yeah, like that.
That's fine.
Then just do all your calculations underneath there. Yeah.
Perfect. Okay. Cool. Right, so looking at question 4, given the geometric series a plus ar squared plus ar cubed plus all the way, we don't know where they're stopping, right? We're going to say they're stopping at n. We don't know what n, if it's a million, if it's a billion, if it's 1,000, right? They're saying where a is the first term, r is the common ratio, prove that the sum to n terms of this series is given by that. So in other words, we just need to prove the sum of a geometric series. Okay, that shouldn't be a problem at all. So now we just need to think, whenever we're trying to find the sum, what is it that we're doing? We're actually adding the terms together. Okay, now they give us our terms. This is just T1, T2, T3, T4, just like that. So if I tried to find the sum, I would actually say Sn is equal to T1 plus T2 plus T3 plus T4. Okay. Now, what I want to do is I'm going to say let the last term be Tn. Okay. And remember, we're dealing with geometric. We know what Tn for geometric is. Remember that Tn for geometric, it is given by a multiplied by r to the n minus 1. That is the last term in this series that we are dealing with. Let's then find the sum. Sn is equal to a plus ar plus ar squared plus ar to the power of 3 plus a number of terms in between. I don't know how many terms, okay? But I know that eventually they are going to come to Tn. Right, let me just erase that. I'm going to rewrite it as ar to the n minus 1. Let me just point that this is Tn. Remember, we agreed that the last term is going to be Tn. It's very important that you understand what I'm doing now, just adding everything up. Then I'm going to call this equation number 1. Okay, now the very same equation 1, I'm going to multiply it by 2 in order to get another equation. Right? Now, I'm going to say r is 8. So I'm multiplying by r. I think I might have said 2 in the previous one. I'm multiplying equation 1 by r. Every single term, I'm multiplying by r. Even the Sn, I'm multiplying it by r. If I multiply this a by r, what am I going to have? I'm going to have ar. If I multiply ar by r, I'm going to have ar squared. Then I'm going to have ar to the 3. Okay? Now, there are still many terms in between. Check what I'm going to do. I'm just going to leave them out. They are still there in between. Okay? Now, the last term, if I multiply it by r, what am I going to have? I'm going to have ar to the n. That's what's going to happen if you multiply everything by r. Maybe I need to do this on the side to show you what I did there. If you multiply that by r, you're just going to have r to the n minus 1 multiplied by r to the 1, because we're multiplying by r. Then, when bases are the same, we consider the exponents. Our a is just a, our r, then our n minus 1 plus 1. These two deal with each other. That's why the last term is just ar to the power of n. Okay. Now, what is the term here? Pretty sure you can see that the term here would simply be ar to the n minus 1. It's just 1 before. Okay? This is what I'm going to call my equation 2. Now, from here, what I want to do is I want to say equation 2 minus equation 1. Okay? Just move on the left. If I did that on the left-hand side, I'm going to have R is in minus S in. It's just this part here. R is in minus S in. This is equal to, check something. I'm going to cancel. AR is going to cancel that AR. Okay? AR squared is going to cancel AR squared. So is AR3 and AR3. Also, all the terms in the middle, so all these terms that are here, are going to cancel all those terms that are there. Okay? AR to the n minus 1 is going to cancel the AR to the n minus 1. But what doesn't cancel? We still have what? We have AR to the n minus a. So this AR in is coming from the second equation because it wasn't cancelled out or it wasn't subtracted by anything. Even this a in the first equation, it didn't have a partner to go with. Okay? Now that we have that, we're going to try and take out a common factor. So on the left-hand side, I'm going to take out a common factor of SA. What's going to be left? R minus 1. This is equal to, what's the common factor here on the right? It's just A. What's left? R to the n minus 1. Now we want Sn by itself. So let's divide by a bracket of R minus 1 on both sides. We know that this is going to cancel that. And on the right-hand side, we have exactly what they are looking for. And our restriction is just if R cannot be 1, because if R is 1, then this is undefined. And that's how you go about the proof.
Okay, so there's just two requests.
Okay.
There's just a request to recap this question and the previous question. So I don't think you need to just do it again. Maybe just sort of 60 seconds. The important steps. Step 1,
Okay.
step 2, step 3. Yeah.
For 4.1.
For 4.1, and someone had asked for question 3 again, but maybe recap this one first, and then you can quickly go back and then just again step 1, step 2, step 3, and then let's do it that way. Just as a reminder to everyone, at the end of the week, we're going to put up all the recordings for the week on our website. So you can just go to the learning space today, and then you'll be able to access the recordings for this session, as well as on TikTok. We'll put up the recordings for the sessions as well. So you will be able to go back and re-watch it. So we're not going to try and recap too much in a session because we need to get through a lot of questions. But you can always come back and re-watch it at a later stage. But maybe let's quickly recap this one, and then the one for number 3, then let's move on.
Okay, thank you, Ernest. I'm quickly going to recap 4.1. Right. So remember here, we're just trying to prove the sum with geometric series. Okay. Now, the first thing that we are doing, right, is it's very important to remember what we mean by sum. Sum means add, right? Because they gave us those terms, we are adding them. So we are saying that Sn is equal to the first term plus the second term plus the third plus however many terms we have in our in our series. We just add them up. We just say Sn is equal to adding those sums manually, adding those terms manually. Right? Then we call that equation 1 because I have an equation. Sn is equal to that. Now, in the next step, what I did is I took the very same equation I had in equation 1 and I multiplied every single term by R. Okay, as you can see, here's the Sa. But in equation 2, I took the very same Sa, I multiplied it by R. Okay, then all the terms as well. A was multiplied by R. AR was multiplied by R. So all terms were multiplied by R. What's very important is the last term. If you multiply the last term by R, what you're going to have is AR to the power of A. This is very important. You need to remember that. If you multiply the last term by R, you're going to have AR to the power of A. Okay. Once you've multiplied everything by R, you simply call that new equation equation 2. Okay, you'll see that now you have 2 equations. Then what you need to do is just from equation 2, subtract equation 1. So 2 minus 1. And if you set that up, you'll see that you have RSN minus SN. So this guy minus SN. Okay? On the right, now you have to eliminate whatever is the same. So in equation 2 and equation 1, whatever is the same, they will eliminate each other out. First thing that you'll notice is that A doesn't have a partner. There's no A in equation 2. We're starting, the first term in equation 2 is AR. Okay? So A doesn't have a partner, it stays there. AR has a partner. AR squared, AR3, even the terms in between, they have partners. Okay? Even the last term in equation 1, AR to the power of n minus 1, it does have a partner. Then those subtract each other out. But what doesn't have a partner is the last term in equation 2, which is our AR to the power of n. That is what is going to be left. So we say RSN minus SN is equal to ARN minus A. Okay. Then what we did is we took out SN as a common factor. Okay, if you take it out, you're going to be left with R minus 1 in brackets. On the right-hand side, what's common? The A is common. You take out A as a common factor. You take it out, you're going to be left with R to the power of n minus 1 in brackets. Then you cancel, you divide both sides by R to the power of 1 because you want Sn to be by itself. And if you do that, you're going to be left with Sn on the left-hand side by itself. These two brackets cancel each other out. Then whatever is left is your answer because that's actually what they wanted us to prove. You can check what we have here is exactly the same as what they have there. And we just put the restriction as well because we know the denominator cannot be 0 for this to work. Okay? Remember, your last term is always Tn, which is AR to the power of n minus 1. Okay, go to the other one. And as it was this one, right? The other one that they wanted to recap on.
Yes, that's correct. Just a quick touch base on the key steps. You don't have to go through in detail. Just step 1, do this, step 2, do that. Yeah.
Okay, perfect. So for question 3, because it's sigma, what is very important is for you to find the first 3 terms so that you know what kind of a sequence you're dealing with. Okay, so you need to find at least 3 terms so that you can find your difference or your constant ratio R. Okay. Now, what they give us there is very important, the key there, right? So they're saying that K starts at 1. So you need to substitute wherever you see K, plug in 1 to get the first term. To plug that in, you're going to get the first term. Then remember, you're increasing. The first term, if we're starting with K to be 1, the next one is going to be 2. Substitute 2 to get the second term. Substitute 3 to get the third term. Once you have your 3 terms, then from there you can check what kind of a sequence you're dealing with. Is it arithmetic? Is it geometric? Okay, we can clearly see from here that this is arithmetic because we have first term and we have a common difference of a minus 4. Okay, now once you have that, you need to state what your first term is, what your common difference is, and how many terms you are dealing with. Okay. Then once it's like that, all you need to do is use the sum to n terms because now you would have evaluated if it's arithmetic or geometric. Because we know it's arithmetic, we're going to use the formula for arithmetic series. Okay, which is given on the formula sheet. Then all we do is we substitute. We have our n, we have the common difference, and we have our a. From there onwards, it's just calculator work because we're looking for the sum to 50 terms. What is most important is the 50. Remember I said that to find how many terms you are dealing with, it's always where you start, right? Always where you start and where you end. So you always say 50 minus 1, but you add that 1 that you are starting with. Okay, so if you want to count manually, you can also do that, but it would be risky if maybe, let's say they gave you 1,000 terms there and you're starting at K is equal to 2. it would take you forever to try and calculate manually how many terms you have. So it's always the top minus the bottom plus 1. That's how you get the number of terms that you're dealing with in that sequence. I'm hoping that's clear.
Thank you so much, Pepper.
Thank you. Okay. Now, let's look at this one. The first two terms of a geometric sequence with constant ratio r and an arithmetic sequence with constant difference d is the same. The first term is 12. Okay, write down the second and third terms of each sequence in terms of d and r. Okay, now let's do this. So I'm just gonna separate them. The arithmetic sequence and the geometric sequence. Okay, so so they said that the first term is 12, very important. So I can simply say this is going to be 12, right? Then the next term, okay, so they're looking for the second term. So if this is T1, T2 would simply be what? 12 plus D, plus the difference, right? Then T3 would simply be what? 12 plus D plus D, which simply simplifies to 12 plus 2D.
So, do you mind writing just bigger, ne?
Okay.
You're on the phone, it's a bit small with that writing.
Okay, right. Let me make it bigger.
Yeah, so write big. If there's space that you need at the bottom, I'll create space. So you can just keep going and scrolling down.
Okay, perfect. Thank you, Ernest. So for the arithmetic sequence, we know that the first term is 12. Is it better?
Yes, thank you.
Then what would T2 be? How do we get the next term? We add the constant difference. So to find T2, we know this would be 12 plus D. Now to find T3, what do we do? It's simply T2 plus the difference. But we know that T2 is 12 plus D. Three here, mistake, 3. There we go. Now this is 12 plus 2D. This is for the arithmetic sequence. Now, let's go to the geometric one. So for the geometric one, the first term is just 12. What would the next term be? Next term would be 12 multiplied by r. Term 3 would simply be 12r to the power of 2. Because remember, we keep multiplying by r. So this is what they wanted. This, that, this, and that. Okay. Okay. It is further given that the sum of the first 3 terms of the geometric sequence is 3 more than the sum of the first 3 terms of the arithmetic sequence. Determine 2 possible values of the common ratio R of the geometric sequence. Okay, so whenever I get a question like this, I want to try and break it down so that I understand it. Okay, so I'm just going to write down the terms. So remember, for A is, what did I have? I had the first term being 12, the next one being 12 plus D, then the other one was 12 plus 2D. And for GS, I had 12, 12R, and 12R squared. The sum of the first 3 terms of the geometric sequence, I'm going to stop there for now. What do they even mean by that? The sum, so of what? Of 3 terms. So I need to add the 3 terms of the geometric sequence. So I need to add this, that, and that. Okay. Now, they're saying it's what? It is 3 more than the sum of the first 3 terms of the arithmetic sequence. Okay. So if I add these up, it must be equal to what? To 3 more. So 3 more means you add a 3. It's not 3 times. It's 3 more. Okay. 3 more than the sum of the first 3 terms of the arithmetic. So I can add. I can say 12 plus 12 plus D plus 12 plus 2D, then plus 3. I need you guys to understand that part. Sum of the first 3 terms of the geometric is 3 more than. So it's equal to this if we add a 3. It's 3 more. Okay. Now let's try to simplify that for ourselves. So here, can't do anything. It's just going to be 12 plus 12r plus 12r squared. This is equal to, here we can simplify 12, 12, another 12. That's 36 plus 3. That should give me, let me write it this way, 36 plus 3d, then plus 3. Okay. Now, let's check what we can do to simplify this. So, what I want to do is I'm going to try and find a common difference or a way to write the common difference. Okay, so I'm going to go back to the question. I think they say something very important. Okay. Remember this part. The same. The first 2 terms of a geometric sequence with constant ratio r and an arithmetic sequence with constant difference d is this. So the first 2 terms are the same, meaning that these 2 things are equal to each other. Hoping you guys understand that part. They are the same. They mean exactly the same thing. Okay. Now, if that's the case, we were talking about these ones that are equal to each other. Then I can say this. 12 plus d is equal to what? It's equal to 12r. Remember, these 2 terms are equal to each other. Then let me call this equation number 1. Right. Even if I call it equation 2, that's fine. The numbering doesn't matter. I can call this equation 2, and then I can call this one equation number 1. Hoping that everyone is still with me. Now, let me solve for d from equation 2. So the common difference would simply be 12r minus 12. Let me call this equation 3. I'm hoping that everyone is still with me for now. Now, what I'm going to do is I'm going to try and substitute equation 3 into equation 1. Let's see what we can do there. So whenever I see difference, I'm going to plug this instead so that I'm dealing with only r. So I'm working, let me just highlight. This is where I am now. I'm going to substitute the common difference in here. So what we have is 12 plus 12r plus 12r squared is equal to 36. Now, instead of writing that common difference there, we know we can write it as 12r minus 12. Then plus 3. Okay, now we have r throughout. Our life is much easier because we can try and simplify this. Okay. Then 12 plus 12r plus 12r squared is equal to 36 multiplied by 12. That gives us 432r minus 432. Then there's a plus 3 there. All right. Now, let's just get it in order of descending powers. So I'm going to bring everything to the left-hand side. 12r squared. Then which ones are like terms? This is a like term. That one over there. So minus 12 gives me 420. And then 12.
So Tebang, there's a comment there.
Okay.
Your first purple line,
Mm-hmm.
just trying to follow with what the comments are saying. The green one says 36 plus 3d plus 3. Your first purple line says 36 into 12r minus 12. And the question is it not supposed to be 36 plus 3 times that bracket plus 3?
Okay. Let me just see. Okay. The difference. I see. It's a mistake on my side. And thank you so much for that comment. I see. So this 36 plus my mistake there. I multiplied instead of adding. I'm going to try and go back up and fix that. Sorry, I actually didn't see that at all. Let me try to fix it. Thank you for noticing that single mistake. So it is 36. There's a plus 3 multiplied by the difference. 12r minus 12 plus 3. I think it's much better now. Thank you so much. Then we have 36 plus 36r minus 36 plus 3. Yeah, because this one multiplied there and there. I'm just double checking that I didn't make any silly mistake. Now we have 12r squared. Then let's deal with the like terms. So we know this subtracts that. 36 from the left hand side, from the right hand side to the left, we are going to have minus 24r. Okay, then now we're done with this part, that part, that one as well. And now all we have to do is the 12 and the 3. So this will be plus 9. This is equal to 0. Okay, and let me see if I can simplify this. If I can divide by 3, 4r squared minus 8r plus 3 is equal to 0. Okay, I should be able to factorize this equal to 0. So if I said 2r and 2r there, it should be fine. Now, positive and negative, negative, negative. Then what I need is just a 3 and a 1. That should work. If I quickly find out first, 2 minus 6 minus 2. Yes, this works. Then it means that our r is 1 over 2, or our r is 3 over 2. And these are our answers for r. Everyone is covered there. On. let's look at this one now, 2.1. Okay, so consider the arithmetic series, minus 21, minus 17, minus 13, all the way until 90. Yes, Noah?
There's requests for you to repeat the question.
Okay, okay.
I think it's the previous one.
Okay, no problem.
Hello,
Okay.
Toga, can you please just confirm which question would you like to have repeated? Okay, so Toga says the previous one.
Okay, no problem. I'll quickly just recap. Okay, so the question first, it said, it is further given that the sum of the first three terms of the geometric series, what, is 3 more. Okay, so the sum of the first three terms of the geometric, I wrote them 12 plus 12r plus 12r squared. Right? They said it's 3 more, so this is very important. 3 more, not 3 times. So 3 more means add 3, right? It's equal to 3 more than the sum. So the 3 more is this part here at the end. Added that 3. Then what? Then the sum of the first 3 terms of the arithmetic. First 3 terms of arithmetic. Term number 1, term number 2, and term number 3 of the arithmetic. Okay, so they are equated them together because that's what the statement said. Now, once you've equated those together, I then went back up because there was an important piece of information. They said that something is the same, right? What is the same? The second terms of those sequences. So T2 in arithmetic and in geometric, they are exactly the same. Okay. Not only those, but even A. The first 2 terms of a geometric sequence, constant ratio R, and arithmetic sequence with constant difference D is the same. The first 2. These ones are clear. 12, 12. T2 is not so clear. That's why they told us that they are the same. What I did is I took that and I plugged it in. So I said 12 plus D is equal to 12R because of the statement that they told me that these 2 terms here are exactly the same. What I did there is I tried to solve for the common difference in terms of R. Okay? Then I got an equation in terms of R, solving for D. That D is what I substituted in equation 1. Remember, equation 1 had R and it also had D. So I wanted to eliminate that common difference, this one here. So I took equation 3 and I substituted in equation 1. So sub 3 into 1. That's what happened here. So the left-hand side, I'm sure you can clearly see it's exactly the same as this part here. Then there's the 36 plus the 3 multiplied by the difference. But we know that the difference is 12R minus 12. That's what we substituted there. Then plus 3 at the end. Then from there, all I did is I tried to get rid of the brackets by multiplying this in. Okay, 36R minus 36 plus 3. From there onwards, it's just basic mathematics, right? Write it in the form ax squared plus bx plus c. It is quadratic because the highest power that we see there is just a 2. Okay, once you're here, I think you know what to do. Because if you don't know how to factorize, please use the quadratic formula. If you're good with factorizing, you can factorize like I did there in order for you to find R. And that's how you go about this question. Okay, I'm hoping it makes sense. Okay, let's look at this one here. Question 2. Consider the arithmetic series. Minus 21, minus 17, minus 30, plus 91. Okay, determine the smallest positive number of the series. Okay, let's try to understand what they're talking about. Smallest positive number of the series. Okay. Now, this is a number that is just greater than 0 because of positive. Okay, so what I'm going to do is I'm going to try and find the nth term of this arithmetic series. So A is negative 21. Let me write it bigger. A is negative 21. Our difference is 4, positive 4. We are adding a 4. Okay, let's find Tn. Tn is equal to A plus n minus 1 multiplied by the difference. This is minus 21 plus n minus 1 multiplied by positive 4, which is just minus 21 plus 4n minus 4. So it simplifies to 4n minus 25. Okay, but I still haven't answered the question. What I'm then going to do, this was very important because all I need to do is I need to say it's greater than 0, right? So Tn must be greater than 0 for it to be a positive number. That's where the greater than 0 is coming from. But what is my Tn? 4n minus 25 is greater than 0. Now, let's solve that. 4n must be greater than 25 by both sides by 4. So n gives you 6.25. Right? Now, because it's giving you 6.25, remember, whenever we're dealing with terms, we said they have to be natural numbers. And the first natural number that is greater than 6.25 is obviously a 7. That's the first natural number that is greater than 6.25. Because you can keep adding decimals there. 6.31, 6.09. First natural number you're going to reach is a 7. Okay? Now, because we got a 7, that's what we're going to substitute. What we're going to say is, we are going to say T7 is equal to minus 21 plus, so we got that 7 there. Let's substitute that 7 in here. So we're going to say this is T7 is equal to 4 times 7 minus 25. Okay, now it's quite easy. 28 minus 25 gives us 3. And that is the smallest positive number of the series. Anything else would be much higher than that. Okay, move on to the next one. Now, the number of
I've got a question here.
yes.
I don't know if it's a question we can contextualize. Sorry, I wasn't focused 100%. But the question from TikTok, Bianca asked, so when are we using the last term in this? I don't know whether it was for this question. Bianca, if you are able to maybe just clarify your question. if you understand it, you can answer it. If not, I'll ask Bentley just to sort of elaborate a bit more on a question, then you can maybe answer it later.
Okay. I think she's asking because this in the series they gave us 91, right? But it wasn't necessary for us to use it at this stage. I'm thinking as we go down in the questions, we will be required to use it. Because now even the next question is saying the number of terms in the series. That's when we have to use the last term there.
Thanks so much. I hope that answers your question, Bentley.
Then the number of terms in the series, that shouldn't be too bad. Remember, we have our nth term. So remember that our nth term was, I'm just going to go up, 4n minus 25. All we're trying to do here is to find n, okay? But we have Tn. It's what? It's 91, as they give us here in the sequence, in the series. That's what I'm going to substitute. When I say 91 is equal to 4n minus 25, 91 plus 25 is equal to 4n. This should give you 116 is equal to 4n, and then n, just divide both sides by 4. We should get 29. So, mistake. It should be a 9 like that. Yes. So there are 29 terms in the series. Okay, moving on. Calculate the sum of the series. Okay. Remember, we have 29 terms. Okay, let me just write here. So n is 29. Then our a was minus 21. Minus 21. And the difference was positive 4. We're adding a 4. We can find the sum. Sn is equal to n over 2a plus n minus 1. Difference. Let's substitute. 29 over 2, open bracket, 2 minus 21 plus 21 minus 21. Sorry. N is 29, not 21, minus 1. Multiplied by the difference, which is 4. Then here, plug it into the calculator. Get your answer being 1015, 2015. And you get your true marks. Okay, then let's look at 2.2. The nth term of the quadratic pattern, Tn that a squared plus b plus c, and the third term of the pattern is minus 1. The values minus 12, minus 8, and minus 4 are the first differences of this pattern. Okay, write down the values of the first 2 terms of the pattern. Okay, so let's see what we can do here. So I'm going to say term 1. So this is the quadratic. I have term 1, term 2, term 3, and term 4. Now, what they gave me is the first differences. Okay. And they also gave me the third term of the pattern. So instead of writing T3 here, I can actually write minus 1. It's given here. Make sure you understand that part. Then they also give me the values minus 12, minus 8, and minus 4. What are those? So minus 12 is here. When you say T2 minus T1 there. So we're going to get minus 12 here. Then here as well, we're going to get minus 8. And then here, what do we have? We have minus. Okay, now it's just a matter of working backwards. So what we're doing is to find T2. We are going to say T2 is equal to minus 1 minus 8. And that should give you T2 to be a positive 7. It's just negative 1 plus 8. Now we have an answer. Positive 7 there. Then it's going to be easy for us to find T1. How do we find T1? We simply say that T1 is equal to 7 minus 12. And that gives us 19. Look at the pattern, it must work out. So 19 minus 12, we get that 7. 7 minus 8, we get minus 1. Then we can find term 4 if they were looking for term 4. Okay? Is somebody saying I'm moving too fast? I'll try to slow down a little bit. Okay. Now, moving on to the next one. Determine the values of A, B, and C. We're dealing with a quadratic. So we had, okay, I'm going to find this as well. So what is the difference here? This is just a 4. Okay, so 4, 12, 19. So if I have 4, a 12, and a 19, this should work. 2a is equal to 4. My a is 2. 3a plus b equals to 12. 3 times 2 plus b equals to 12. And b is equal to 6. Here we go. Minus. Forgot my minus there. It's going to mess everything up. Because remember, this is 2a, this is 3a plus b, and this is a plus b plus c. I omitted that minus there, which is going to cause me problems. So let me just quickly rectify that. So 3a plus b is minus 12. And we know this is 3 multiplied by 2 plus b equals to minus 12. Then our b is going to do minus 18. Okay, now we can find our c. A plus b plus c must be, let me check if that was a positive 19. Yes, it's a positive 19. 19. 2 minus 18 plus c equals to 19. Okay. Then our c is going to be, it's going to be minus 16, 19 minus positive 35. Because when it goes to the other side, it becomes positive 19 plus 16, gives us 35. Okay. They just say determine the values of A, B, and C. They didn't look for the nth term, But if they did, that's going to be quite easy. We have our A, we have our B, and we have our C. I'll just plug it in there. Tn is equal to 2n squared minus 18n plus 35. Okay, and remember, you can check that this works by substituting the first few terms. So you can make n1. If you make it 1, it must give you 19. If you make it 2, you must get 7. If you make it 3, you must get minus 1. If you're not getting those, then there's a mistake somewhere. Okay. Now, which term of the pattern is equal to 139? Okay. So remember what we have. Our nth term Tn is equal to 2n squared minus 18n plus 35. We need to then equate this to 139. Okay, if we equate that to 139, just going to say 139 is equal to 2n squared minus 18n plus 35. It's a quadratic that we can easily solve. 0 equals to 2n squared minus 18n. Then this will be minus 35, 39, 104. Okay, can divide throughout by 2. 0 is equal to n squared minus 9n minus 52. Quadratic formula, if you can factorize this. Alternatively, you can just try to factorize it. So n and n, that's the only way I can get n squared. Then the factors are 52, that's divisible by 2, 26 and 2. Possibly, but no, because 26 and 2, it's going to give me 28 or 24. Then 26 can be divided by 2. 13 and 4 will give me, if I multiply them, I'll get 52. 13 and 4 will give me 9 as well. So I'm going to say minus 13 here and positive 4 because I need a negative 9. So my n is 13 or n is minus 4. Okay, then this one is not applicable. But why is it not applicable? Remember, I said to you, if I give you a pattern and I said find term 1, you'll be able to find term 1 because that's where it's starting. But if I said find the term negative 1, you can't do that. Okay?
Okay. So, Bang, I've just put a question there as a bit of a break, which is a quiz question for everyone to try, and then we can jump into the Q&A after that.
Okay, awesome. Thank you so much, Ernest. So let's all attempt that quiz question on the screen. Right, let me just read it out for everyone in a sequence with each term after the first term. After the first is the sum of the previous 2 terms. And the first 2 terms are 1 and 1 respectively. What is the sum of the first 10 terms? A hint would be to write the terms out. So maybe quickly just attempt this question. And this is 3 minutes enough for them to attempt it.
I think 3 minutes is enough, yes.
Okay, perfect. I'll give you guys 3 minutes to quickly attempt this question before we look at it together.
Okay, cool. And then when you've got it, just post your answer A, B, C, or D in the chat. Also, we will give bonus points to whoever can tell us what type of sequence or pattern this is.
Okay, I'm already seeing answers in the chat. I'm seeing B, I'm seeing C. Okay.
Remember again, guys, if there's bonus points to whoever can tell us what the type of sequence is as well. But thank you for everyone who's answering so far.
Awesome. Thank you so much. If you know what kind of a sequence this is, you can quickly just type it in the chat before we go over the answer together. I also did the question with you guys because I didn't know the answer and I got something very strange. So we'll look at it together here on the screen. Okay. Tapelo Mnisi said it's geometric. So did Linda. Okay. All right. Ernest, I'm going to go for it. I think I've given everybody enough time.
Yes, you can go for it.
Okay, perfect. So I'm going to go for it the way I understood the question. And
100%.
if I misread it, you will correct as well. I saw it for the first time. Okay, but let's
No,
just
it's perfectly
see.
fine. It
Let's
is a
just
trick question, and hopefully you picked up but it's fine. Go for it.
Okay, so I could be very wrong because my answer is none of those options there, which is very strange, right? But let me just explain how I got my
Not strange.
answer.
You're correct.
Okay.
So not strange. So if the answer you got, someone posted there, Uteng posted in the chat. I'm getting
Somebody
an answer
posted
that
it.
isn't part of the multiple choice. Uteng is going to get 10 points from me. And then Uteng, you'll get 10 extra points if you can tell me what type of sequence this is. So that's the first thing. The answer isn't actually on the screen. I want to see how good you guys are.
Uteng, can you maybe post what answer you got? You might get yourself some data, hey? Just tell us which. Okay, there's Dineo who got 143. Dineo Cody got 143. Uteng also got 143. Okay. Oh, wow. Awesome. Awesome, guys. That's what I got as well. But let's see if we're not sitting with a misconception here. Let's break it down for the ones who didn't get it, or for the ones who are saying it's B. Okay. So what we need to remember here is they said that in a sequence where each term after the first term is the sum of the previous two terms, and the first two terms are 1 and 1. So the first two terms. So here's term 1, it's 1. Okay, let me maybe change my color. Sorry. So it's 1. Term 2 is also 1. Now, what do we know about the third term? The third term will simply be 2. Where am I getting this from? Each term after the first is the sum of the previous 2 terms. So for me to get term 3, I need to sum the previous 2 terms. Okay? Now to find the fourth one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So to find the fourth one, it will be 3. How is it 3? Because it's the sum of the previous 2. The fifth one, it will be 5. The sixth one will be 8. Seventh one will be 13. The eighth one, 21. And this one should be 34. Then the last one should be 55. Then all you do is you add everything up. And this should give you 134. And that is how you deal with this question here. Did anybody tell you what the sequence is called? Sorry, 143. Sorry, 143 instead of 134. 143. I stopped before the 3 around. Sorry, thank you, Chato.
I haven't seen anyone that gave us the sequence, but you can scroll down. The question, the answer is there. If you scroll down a little bit,
before I give them, I wanted to
give them
a chance.
The answer for the name of the sequence is not there. That's
okay,
the question I thought of afterwards. Yeah.
Okay.
Yeah. I just put there the answer, none of the above, with the correct answer.
So thank you, Ernest. But does anyone know what sequence this is?
We have some answers. TikTok, Bianca says arithmetic sequence. There's some people here in the chat that did give answers. Some people saying geometric.
Okay, all right, I see. Actually, it's not geometric, it's not arithmetic, it's not even exponential, but this is what we call a Fibonacci sequence. It's just one in Fibonacci sequence. Whenever you have time, let's just go to Google, go to YouTube and check out the Fibonacci sequence. It's a very cool sequence to deal with.
And for those that joined the session early and the ones that saw the intro sequence, I had put a clue at the very beginning of the session for this quiz question. So if you go back and you have a look, maybe can I try share that video again? And
yes, you can. I can stop sharing on my side.
That I left. Let me quickly try and see if I can get it on.
Okay.
At the very beginning of the session. Right there at the very beginning of the session. It was a little clue to our quiz question for the day. So well done to those that got the sum. And then next time we'll try and bring in a few more other interesting questions that we can deal with. And I encourage you guys to go do some research on the Fibonacci sequence. It's a very fun sequence to deal with. There's a lot of places where it occurs naturally just in nature. It's quite cool. Maybe Tapang, you can put your whiteboard back up and then we can jump into the Q&A session for the day.
Awesome, awesome stuff. Thank you. Right, I'm sharing again. Can you see my screen?
Yes, I can.
All right, perfect. All right, guys. Now we have a few minutes left, about 14 minutes left. Now's the time. If you have any questions, maybe just please post them in the chat, or just raise your hand and we'll try to unmute you so that we can try and answer some of the questions that you guys might have. Please use this opportunity to ask any questions that you might have on your side so that we can try to assist you. All the way up. I think, Ernest, maybe they are still trying to get those questions. I don't know if I maybe can do the proof for the arithmetic sequence while maybe they gather their thoughts and just try to find the questions, or if I should just wait. I think maybe there's a question in the chat actually. Oh, okay. So somebody's asking me to do 4.2.2 again.
Yes, sorry, Duncan was there. I was speaking on mute. Apologies. I didn't realize you couldn't hear me.
Okay, no problem. 4.2.2. All right. So let's check what's happening here. Yeah, so it's very important for us to understand the wording in the question. Okay, otherwise we're going to mess this thing up, right? I'm going to try and highlight what I think is very important there. The sum, right? What do I understand by sum? I need to add, right? The sum of what? Of the first three terms of the geometric sequence. So if I add three geometric terms, the first geometric terms together, right? They will be equal to what? So let me just highlight it. The sum, just in terms of the geometric sequence, is 3 more than the sum. So this is very important. 3 more than the sum of the first three terms of the arithmetic. Let's try to break that down. First three terms geometric, I wrote them down here. No problem.
Sorry to interrupt, Tapang. Ne?
Yes,
someone wrote, could you start with 4.4.1? But I think they might have meant 4.2.1.
4.2.1. Okay.
So that we know where we get those values in the first place.
Okay. Maybe let me go about that one instead.
Yeah, start there, then we can jump into 4.2.2.
Okay, no problem at all.
Sure.
Okay, so let me just erase so I can quickly maybe just do this one for you guys instead of just talking through it. Okay, the first two terms of a geometric sequence with constant ratio r and an arithmetic sequence with constant difference d is the same. The first two. Okay, this is very important. The first two terms of a geometric sequence, right? And arithmetic, right? Now, let's say arithmetic sequence. What is the first term of that arithmetic sequence? It's given. I'm sure you guys can all see it. The first term is 12. Okay? What would the next term be in that arithmetic sequence? It would be 12 plus d. Okay? We just wrap it in brackets like that. Then what would the third term be? It would be 12 plus 2d. Are we all together? Now, let's look at the geometric one. What is the first term of this geometric sequence? It's also 12. Okay? Where am I getting the 12? They say the first term is 12, and the first two terms are equal to each other. Now, for geometric, the second term would be what? 12r. What would the third term be? 12r squared. Okay, now it's very important that we understand that these two are equal. Okay, not only those two, but these ones as well. Because those are just 12. Okay? We wrote down those terms. Let's jump to 4.2.2 now. Okay. It is further given. Okay, let me just, I'm going to try and do it quickly. Okay, let's do it. Sum of the first three terms of geometric. So I'm going to say three terms of geo, right? The sum of them. Sum of three terms of geo, what are they? Let's go back. 12 plus 12r plus 12r squared. That's what I'm going to write here. So 12 plus 12r plus 12r squared. Okay? What is this equal to? It's equal to what? 3 more than the sum. So 3 more. So I'm going to say equals to 3 more. Then what? Then the sum of the first three terms of the arithmetic. What are those? 12 plus 12 plus d plus what? Plus 12 plus 2d. It's important that we understand what I did there. Okay, now let me use a different color. Remember something. What did we say? We said that these two things are equal to each other. These ones in a bubble. So 12 plus d is equal to 12r. 12 plus d equals to 12r. It's going to write it there on the side. So 12 plus d is equal to 12r. Okay? I'm going to call this equation 1. Let me rather do that. Now that we have that, maybe let's solve for the difference. So d is equal to 12r minus 12. Okay? Or maybe to make it easy, I can start calling it 1 from here instead of having many equations. Now, if I call that 1, then this would be 2, or vice versa. It doesn't matter. Okay, maybe let me go in this order. Say this is equation 2, and this is equation 1. Okay, then I'm going to substitute sub 2 into 1. So what do I have? 12 plus 12r plus 12r squared is equal to 15 right? Plus 12 plus 12 plus 3D. So just say 3 plus 12, they give me 15, then I got rid of the brackets. Okay? Now, I'm going to try and simplify even further before I substitute, or I can substitute now because I said substitute. Okay, so whenever I see D, I know that it's this. So let me get rid of that and say 12R minus 12. Okay? Let me just make space, get rid of this. Go. Perfect. So then 12 plus 12R plus 12R squared is equal to, then let's add. So 24 plus 3 plus 15, get 42 there. So not plus 3, not plus 3, the 3 is multiplied there. Sorry. So 15 plus 24, 39 plus, now this needs to multiply in. 36R minus 36. So these were added. I'm hoping that everyone's still with me. Now let's simplify, right, in ascending powers, or descending powers rather. 12R, okay, now it's going to be minus 24R because this comes to the left-hand side, and then there's a 12. Then I'm done with this and that. I'm done with that as well. Now 39 minus 36 is just 3. 3 will go to the left-hand side. It will become negative, so I have plus 9 is equal to 0. Okay, over the squared there. My mistake, forgot to write that squared. Now divide throughout by 3. 4R squared minus 8R plus 3 equals to 0. Factorize for quadratic formula if you can factorize it. 2R, 2R, minus minus because of the positive. It has to be 3 and 1. That's the only way it works. Then R is equal to 3 over 2, or R is equal to 1 over 2. As simple as that.
Thanks a lot, Tapang.
Awesome. Thanks,
Apologies.
Ernest.
So,
No
so were you
problem.
done with the question?
Yes, I'm done with the question because it wanted us to find the values of R, and that's exactly what we did. 2 possible values of the common ratio.
Okay, perfect. I know we're out of time, but there was a really nice question from the TikTok group. Let me quickly find who gave the question so I can give them the flowers for that. Rita on TikTok asked, how do you calculate the value of the smallest term in a quadratic pattern? I like that question so much.
The smallest term in a quadratic pattern.
Yes.
Okay, perfect. So I think I can take that one. Now, remember that quadratic patterns, right? The most important thing is the term quadratic, right? If it's quadratic, think of a graph, a parabola. Okay, so in a quadratic pattern, you can either get what? The highest possible or the minimum possible, because you're thinking of a graph, right? A quadratic graph is a parabola that has a minimum turning point, or a sad face one, which has a maximum turning point. Okay, so if they are asking the minimum value, they just want you to find the turning point of that sequence or of that graph. Well, the sequence doesn't have a turning point, but because if you find the formula, right, in the form n squared plus bn plus c, it can be a quadratic graph. We can find the turning point. Remember turning point, x is equal to negative b over 2a. Right? Even for maximum, we're still going to use minus b over 2a. So it just depends what they ask you.
Can I ask, maybe you make an example out of, so there's a quadratic equation on your left-hand side,
Okay.
which let's assume our quadratic pattern equated to that. Let's call it 12t squared minus 24t plus 9. And then let's quickly just do it so we can give them the answer, if you don't mind.
So you want me to say 12n squared minus 24n plus 9 is our Tn.
That's our Tn. There we go. Yeah. So
Okay.
either we can use that, or there was a quadratic equation somewhere we were doing, but let's use that one. Let's assume that was our Tn. Yeah.
Okay, no problem. So if this is our Tn, so the question that they will ask here, right, is what is the minimum value that we can get in this sequence? Why am I'm already seeing that it's minimum. Why? Because of my A value. You guys see that? Remember, this is in the form ax squared plus bx plus c. Because our A is positive, we know we are dealing with a graph that is happy face, right? We don't have a maximum turning point, we have a minimum turning point. But in this pattern, we have a minimum number. Okay, so what are we going to do? I'm going to say x is equal to negative b over 2a. Okay, so this will simply be minus 24 over 2. What is the first term? It's just 12. Okay, then it's just 24 over 24, which gives us 1. Okay, now that we have 1, what do? We need to sub it back into our equation, right? So we are going to find 12, 1 squared minus 24, 1 minus n, and check what that gives you. Okay, you can quickly do that. And this gives you minus 21. And this is the smallest value that you can get in this sequence.
Thank you so much, Tsapang. I think you can wrap now. Yeah.
All right. Awesome. Thank you so much, guys, for joining. I'm hoping that these sessions really do help you out. We will see you tomorrow for physics. From the top of my head, I can't remember what we're doing tomorrow. But yeah, Ernest is going to be helping you guys out with tomorrow's session. I'm hoping to see you all tomorrow. Enjoy the rest of your evening. Thanks, guys.
Thank you so much, Tsapang, for that wonderful presentation. And as we wrap up for the day, guys, thank you so much for joining. Please remember that these sessions are very important as we're leading you guys down to your prelims. We're leading you guys to wrapping up this year. We want you guys to do really well. And as we do that, we encourage you guys to join the sessions every day that we are going to have here, right? So as we have these sessions, as we join these sessions, please ensure that you invite your friends to come. Those guys that are watching us on TikTok, thank you so much for engaging. Thank you very much for doing everything you guys do to make these lessons awesome. Please share this live. Please follow us. And everyone that's watching on Zoom, please go to TikTok. Follow us on TikTok. We post a lot of great content to help you, especially now leading up to your guys' exams. We really do appreciate everything you guys do to engage with us. And we will see you guys tomorrow. Please remember, if for the guys on Zoom, if you do not attend, you will not be receiving your data to attend the next session. It is very, very important that you guys do attend the session. So thank you very much, guys. Have a great rest of your session, and cheers. See you guys tomorrow.
Ernest, I think we're waiting for your nice outro.
I know, I'm trying to find the music. Let me let me get my music going for the day. Give me 2 seconds. Guys, thank you so much. We will see you guys tomorrow for the physics lesson. Enjoy your evening. Stay blessed. Stay great. See you tomorrow.